Question 12, which property decreases on descending? Descending is going down. Your group 2 now these days are using this numerical number instead of using this Roman numeral. The radius of the cation doesn't decrease because you have more filled electronic shells, so definitely your radius definitely get bigger. Okay, reactivity of the element with water, that actually increases because your valence electron is easier to be lost since they are further away from the nucleus. And think about what we just said, more filled shell, so they are more shielded, so easier to be lost. And therefore, if you are easier to lose your outer shell electrons, that means that makes you more reactive as a metal. Okay, shielding of the outermost electrons does increase because of more filled electron shells. And last but not least, the thermal decomposition of the carbonate as the radius of the cation increases, but the charge of the cation is still +2. So what we say is the charge density of the cation, the M2 plus cations, would decrease because the charge the same, the size increases, charge over volume, charge density would decrease, therefore they are less polarizing. You will learn more about this in the A2 essay. The cation is less polarizing on the anions, therefore harder to decompose or not as easy to decompose, so harder to decompose. So what do they want actually? What do they want? The ease of thermal decomposition. The ease of thermal decomposition. It becomes harder to decompose, means it becomes less easy to decompose, and therefore D is the only possible answer there. Question number 13, what we have here is aluminium powder reacting with anhydrous barium nitrate, and you're told that you only get the metal oxides. In that case, you get the Al2O3 as well as the barium oxide, and you produce nitrogen as the only product. So this seems like a stoichiometric calculation kind of question. So what we need to do is we need to have a balanced chemical equation before we even attempt in order to get the answer. Okay, so Al2O3 plus barium oxide plus nitrogen gas. So balancing the equation looks like 2 aluminium. So what I'll do is I'll have 2 aluminium on the left hand side, and the barium is balanced, 2 nitrogens, and the oxygen. There are 6 oxygen atoms. There's 3 and there is 1. Wonder if I've done anything wrong. Aluminium powder, barium nitrate, aluminium oxide, barium oxide, and the nitrogen. Let me see. The aluminum is balanced, barium is balanced, nitrogen is balanced, oxygen there's 6, so perhaps I need to raise the oxygen a little bit. So if I have 2 of that, then 2 of that, that doesn't seem to help, does it? 6. I wonder, hang on, let me see. Okay, how in the world are we going to balance this equation? 2 aluminium. This is tricky, isn't it? Can I balance this? How much longer will I need to balance this? Okay, let's see what we can do without balancing it. Okay, so in terms of the nitrogen, there is 2 nitrogens, but the oxygen is not balanced. That's all I can tell you at the moment. The oxygen is not balanced, obviously. It seems like there is 6 oxygen, there is 4 oxygen there. But what else do we know? Okay, they did say metal oxides. They never say that it has to be Ba, or could be, I don't know. Okay, well, let's have a look at the question first. All right, so what volume of nitrogen? So because you know, like sometimes in mole calculations it might not be something that you need, right? So based on the atoms, the aluminium, the barium, and the nitrogen, that is definitely balanced. Based on the nitrogen, so there's 2 nitrogen atoms that comes from 2 of these nitrogen in the nitrate, barium nitrate, Ba2 plus NO3 minus, and it's produced from these barium nitrates. So very clearly, if you don't have any nitrogen in the products, the nitrogen must come from the nitrate because it didn't react anything with the nitrogen. So I think very clearly we can establish that the mole ratio of the N2 is to the barium nitrate. So one of these barium nitrate give you the 2 nitrogen atoms, therefore give you one of that N2 molecule. On the right hand side, I want the volume of the nitrogen gas, and these are in cm cube, and these are at room temperature and conditions. So I have to have molar volume of gas, which is 24,000 cm cube per mole. This is the same as 24 dm cube per mole as stated in your periodic table. So this is my volume of N2 divided by 24,000, because my volume of N2 there is in cm cube as stated in the option there. At the bottom, I'll have 0.783 gram divided by the molar mass of this barium nitrate. So go straight to your periodic table. Barium is in group 2, so there's 137.3 plus 2 times, so 2 times the bracket 14.0 times 1 plus 16.0 times 3, and I get 261.3 at the bottom. So rearrange your equations. The volume of nitrogen will be 0.783 divided by 261.3. You move it out to the other side is times 1, but then I can also move out my 24,000 to the other side, and I'll get 71.9. This will be in cm cube. The closest answer there is 72.0 to I don't know, perhaps that I've made a rounding error, but then 72.0 is the closest to the answer there. I tried doing this question by trying to balance the equation, but this question is clearly not balanced. But I could clearly relate that the nitrogen will be 1 mole of it, since I have 2 nitrogen atoms. They come from the 1 mole of these, there's 2 nitrogen atoms as these stoichiometric ratio, since none of the other reactants and none of the other product contain nitrogen there. Hopefully that makes sense to you. In this next question, question 14, chloride of a period 3 elements is in the syllabus, and you want to form a solution with a pH of 7. So this one is a direct factual question. Sodium chloride just give you NaCl, Na plus, and also Cl minus. So what happened is that plus water, they just give you Na plus and Cl minus. They just dissolve without hydrolysis. But this one, SiCl4, does get hydrolyzed to give you this white precipitate, which is insoluble in water. And you also get this acidic solution with the HCl, steamy white fumes. Some of it could dissolve in water and give you an acidic solution. Okay, PCl5, phosphorus 5 chloride is phosphorus plus 5. When you add it with water, you're going to get phosphoric acid, which is PO43 minus. So you also get HCl as a result of hydrolysis. You get 5 HCl, and to balance the equation, how do you balance this equation? 5 hydrogen, so you need 4 of that H2O there. Aluminium chloride is also hydrolyzed, and eventually what you will get is you get the AlH2O6 3 plus. As a result of the small size of aluminium and the high charge of the aluminium, the Al3 plus is very, very high charge density, very polarizing, and it will result in the dissociation of these oxygen and hydrogen covalent bonds, resulting in hydrolysis. This will give you a pH of around 3 in solution, slightly acidic there. Question 15. So which row correctly compares the electrical conductivity and the first ionization energy of magnesium and aluminium? So if you think about the first ionization energy, we know that there is an increase, a drop, an increase, and then a second drop, and then a further increase, and then all the way down there. So we know that this is first ionization energy. So across the third period, there's magnesium and aluminium. As you feel across the 3s to the 3p, you're removing from the 3p subshell, which of course is slightly further away from the nucleus. As you can imagine, your nucleus is in the center. So when you're there, you are slightly blocked when you're in the p subshell. You're slightly more shielded, further away from the nucleus, therefore slightly easier to remove. This one there is going to be phosphorus and sulfur as a result of your paired electrons repelling more than unpaired electrons. That thing there is a noble gas, and then you fill in the new shell, which is potassium, which is further away, more shielded, slightly easier to remove that. But we are just looking at magnesium and aluminium, so higher first ionization energy has got to be the magnesium and not the aluminium. There's the conductivity. We know that from sodium to magnesium to aluminium, conductivity depends on how many of these valence electrons that you can delocalize into. The C of delocalized valence electron obviously would increase going from sodium, magnesium, aluminium as you go from group 1, group 2, and group 13. So higher electrical conductivity will be aluminium and not magnesium. So B must be the correct answer there. Question 16. So this thing has been taken out from the syllabus from electrochemistry, so you will no longer find electrolysis in the AS electrochemistry topic. Regardless, it's something that you have done from your O level. So NaCl, Na plus, Cl minus, H plus and OH minus. When you have these concentrated aqueous solutions, we know that it will favor either discharge of the Cl minus, giving you chlorine at the anode. So anion goes to the anode as the anode is positively charged, and then between the H plus and OH minus, the H plus goes to the cathode as the cathode is negatively charged. And you have reduction at the cathode where the H plus gain electrons, and you have oxidation at the anode where you have loss of electrons at the anode, and you have reduction, which is gain of electrons at the cathode there, leaving you behind the what was I gonna say? Leaving you behind the OH minus and Na plus, and therefore overall you can imagine the NaCl. To balance the equation, I need the H2O there, giving me NaOH, giving me H2, giving me Cl2. To balance the equation, 2 NaCl there, 2 NaOH, and I need 2 water as well to balance the equation. So in terms of what is happening, if I have 58.5 kilogram, these are reacting masses. So if I have 58.5 kilogram divided by the molar mass of NaCl, if you do the MR of NaCl, that is going to be 58.5 as well. So 23.0 plus 35.5. So yep, I do get 58.5. So that is considered 1. So of course, I don't say it's 1 mole because technically speaking, this is in kilogram. Technically speaking, I have to convert it to gram in order to get, mass over MR. The mass has to be in gram. So I don't want to say it's 1 mole, but I'm going to talk about reacting ratio. Okay. So in terms of the reacting ratio, 2 mole of that give me 2 mole, 1 mole, and 1 mole there. If I have 1 there, so this is going to give me NaOH is to H2 is to Cl2. Therefore, I'm expecting this one will be 1 because 2 give me 2, 1 give me 1, 2 give me 1. So when I have 1, I will have 1 over 2, which is 0.5. Okay. If we just think about it in terms of mole, but then we will get gram. But instead, because we use kilogram here to get our answer, mass of MR, so our answer here in terms of the masses would actually be in kilogram as well. So work out the MR of NaOH. So that will be 23 plus 16.0 plus 1.0. That is 40. And then 2 times 1.0 is 2. And then 35.5 times 2 is 71. So these are the mole, considered as mole, multiplied by the MR. It's going to give you the mass. So I'm going to get the masses of the product. 1 times 40 is 40 kilogram. And then 2 times, am I correct? 2 times a half, they will give me 1 kilogram. And last but not least, 71 times a half, they will give me 35.5 kilogram of the chlorine. What do they want? The yield of the chlorine, 35.5 kilogram. The yield of the hydrogen, I will get 1 kilogram. The yield of the sodium hydroxide, I'll get 40 kilogram. So A is the only correct answer there based on the mole ratio and the reacting amount, and therefore the amount of product you get. Question 17. So we have a reactions between sodium chloride. So it's a chloride iodide with consulfuric acid. When doing this type of questions, as you will know from my other MCQ topical playlist on group 17 chemistry, so you have this oxidizing power. If we talk about the oxidizing power, we know that Cl2 is more oxidizing than Br2 than I2, and we know that consulfuric acid lies somewhere in between the oxidizing power of Br2 and Cl2, so that it doesn't oxidize chloride to chlorine, but it can oxidize bromide to bromine, it can oxidize I- to I2. So in terms of sodium chloride, the consulfuric acid will just give you a colorless acidic gas because it just do a acid-base reaction that will be happening together with the other acid as well. So what do we know? So conphosphoric acid does the exact same thing with iodide. It doesn't even give you the purple vapor. So what it tells you is the conphosphoric acid must be weaker oxidizing agent. It must lie even further, even weaker than I2. That means this thing, conphosphoric acid, cannot oxidize I- to I2, but consulfuric acid can oxidize I minus to I2 because consulfuric acid is a stronger oxidizing agent than I2. It can oxidize I minus to I2. That's why you get iodine vapor. The iodine vapor there is purple. So what happened there is you get a redox. And this thing is just colorless acidic gas there because no redox, you just get acid-base reaction. So based on these are oxidizing agent. So corn-phosphoric acid is a stronger oxidizing agent than corn-phosphoric. That is actually wrong. It's actually a weaker oxidizing agent. So A is wrong. Corn-phosphoric acid is a stronger oxidizing agent than iodine. That is again wrong. It's actually weaker based on the positions in this oxidizing power line diagram, which I've just drawn qualitatively. Consulfuric acid is a stronger oxidizing agent than chlorine. That is wrong because it doesn't result in any pale green chlorine gas being formed because it doesn't oxidize chloride to chlorine. So it's actually a weaker oxidizing agent than chlorine. But consulfuric acid is indeed a stronger oxidizing agent than iodine. That's why you can oxidize iodide to iodine. So I minus in the I minus going to iodine 0 in I2. These are the oxidation number you have learned in AS chemistry as well as O-level, GCSE level or IGCSE level chemistry. Question 18. So this white powder is a mixture of sodium chloride and sodium iodide, and you add excess silver nitrate to it. So you do get a precipitate, and this precipitate will be a mixture of AgCl solid, which is white in color, as well as AgI, which is yellow in color. So you get some yellow precipitate, you get some white precipitate. Now you also add in some excess concentrated ammonia, and we know that this white precipitate AgCl will dissolve in ammonia, especially when you have concentrated ammonia and also in excess. This one, the yellow precipitate or silver iodide, is insoluble in concentrated ammonia. So after the test has been shaken, you still get a precipitate. So what can you see in this precipitate? Only AgI, therefore only yellow precipitate. So when you say it's pure silver chloride, which remains a precipitate, so that thing is wrong because Y is just silver iodide precipitate. Y is only that. What else? Y is yellow, so that is correct. X is pure silver iodide. Well, X is the mixture. So think about X. X is there, whereas the Y is just the insoluble yellow precipitate of silver iodide remaining. But X is going to be a mixture of these two because you haven't separated them with the use of concentrated ammonia yet. X is not going to be pure white. It's going to be a mixture of white and yellow. So it's not a pure white because it's a mixture. So X is mixture. So A and B are wrong. You want correct statement. D is definitely the only correct answer there. Question 19. So we have a calculation question here. We have an ammonium salt. This ammonium salt gives you ammonia gas. So which ammonium salt was used? We can think back on our ionic equation from your O-level, your GCSE or IGCSE level chemistry. When you react it with hydroxide, this is your test for ammonium ions. You heat it up and then you will produce NH3 gas and also H2O. This is ionic equation. We must have stat symbol. We must have balanced charges. So plus 1 cancel minus 1. What is happening in terms of the chemistry is that this one is the base. Base will accept the H plus is a base, whereas acid will donate the H plus, and that's why you form the NH3 later on. So which ammonium salt was used? You have the mass of the ammonium salt, you have the volume of the ammonia gas. This is at room temperature and pressure. This is in dm cube. So you need to consider the molar volume of gas as stated in your periodic table. It's 24 dm cube per mole of any gas. So you can see that 1 mole of NH4 plus give you 1 mole of NH3 there. So that means if I have the mole of the NH4 plus is to the mole of the NH3, they're going to be 1:1. So I will have 4.70 gram divided by the MR because there's mass over the MR of the ammonium salt. But I have an issue here because this is one of the ammonium ions, whereas when you look at the formula for all of these, this is ammonium bromide, NH4 plus Br minus. That one is nice and easy. Ammonium carbonate is not as easy because it's NH4 plus. You need 2 of it. and you have 1 of the carbonate. Ammonium nitrate, you need 1 of the nitrate and 1 of the ammonium ion. Ammonium sulfate, just like the carbonate, you need 2 of these ammonium ions, and you only need 1 of this sulfate ion. So let's work out the MR first, but then be careful because these ammonium ions, you have 2 mole of this ammonium ion in the carbonate. So we need to be very careful of what we're doing in this particular case, okay? I'm just going to put in the value first. So 1.41 dm cubed for the gas divided by 24 dm cubed. So I'm just going to work out the MR. Maybe it's better if I just show you how it works. I move up the number. So be very careful about having so many equal signs. So these are not equal to this because I have rearranged it. So I use an arrow to represent that it is not equal. But then I want the MR. So the MR will go up. The 1.41 will come down. The 24 will go up to the other side. So it's 4.70 times 24 divided by 1.41. This all comes down to mathematics as well as rearranging equation. So what I get as the MR is 80. And you will see that there is an 80 here. So most likely this is the answer, the ammonium nitrate. What I'm saying earlier is that the MR is actually a result of the whole molecule, the compound. Okay, so here I'm a bit lucky because it gave me 80 exactly. But if this answer doesn't correspond to any of these, I have to consider that this MR might not represent whatever is there, because the mole of ammonium ions, I will have 2 mole of ammonium ion in 1 of ammonium carbonate. I will have 2 mole of ammonium ion in 1 of ammonium sulfate. So just be aware when your answer is not exactly equal to the option given there. Here is alright because it gave me exactly MR equal to 80 for the ammonium nitrate, which you can check because here 1 mole of these will give you 1 mole of ammonia. 1 mole of these will give you 2 mole of ammonia, just like 1 mole of these will give you 2 mole of ammonia based on the formula. Question 20. Which ester is formed when you have this alcohol and when you have this acid? This is a 1, 2, 3, and 4. This is a 4-time carbon acid. It's called butanoic acid. So you should know how to name ester. This is a 2-carbon alcohol. This is called ethanol. When you have ester, you will have C double bond O, R and R dash. This bit with the carbonyl on the left hand side is your carboxylic acid fragment. Don't forget, you have 1 carbon already in this carbonyl fragment there, and you have this alcohol, which will give you the alkyl part of the name, and the carboxylic acid will give you the carboxylate part of the name. So based on the ethanol and butanoic acid, you will get the ethyl first, and then you will get the salt, which is called butanoate. So ethyl, butanoate. If you have to draw it out, you can draw ethanol, and then you will draw carboxylic acid, 4 carbon, 1, 2, 3, 4. So when they condense together, you will get a carboxylic acid that looks like this, 1, 2, 3, 4, and then 1 and 2. So you can see the ethyl butanoate. So B is the correct answer there.